Hello students, today's topic is Laplace Transforms of Periodic Function and Dirac Delta function. Okay, what is periodic function? Periodic function is a function that repeats its values at regular intervals. For example, this is a periodic function, right? This is period P. Okay, the periodic function is a function that repeats its values at regular intervals. Okay, now let us see the definition. Periodic function. A function f of x is said to be periodic. Is said to be periodic if there exists a non-zero constant p. If there exists a non-zero constant p such that f of x is equal to f of x plus p for all values of x in the domain. Okay, here this p is called, the non-zero constant p is called period. Is called period of the function f of x. Okay. If there exists a least, p, non-zero constant p with this property, then that p is called fundamental period. Fundamental period. Okay. Generally, period of a function is used to mean its fundamental period. Okay. For example, sin x, cos x are periodic functions. Of period of period 2π. Okay. Now, what is the Laplace transform of periodic function? Laplace transform of periodic function. Let f of t be a periodic function. Let f of t be a periodic function with period t. With period t. Then the Laplace transform of f of t is equal to 1 by 1 minus e power minus st integral 0 to t e power minus st f of t dt. This is the Laplace transform of a periodic function f of t with period capital T. Okay. Now let us look at a problem on Laplace transform of periodic function. This is the problem. Find the Laplace transform of the periodic function. Find the Laplace transform of the periodic function f of t equal to sin t if 0 less than t less than pi by omega, that is 0 if, this is sin omega t, if phi by omega less than t less than 2 pi by omega. period. This is the periodic function of period 2 pi by omega. Okay. Now I have to find this its Laplace transform. Solution. Given f of t equal to sin omega t if 0 less than t less than pi by omega, that is 0 if pi by omega less than t less than 2 pi by omega. Okay. And this is periodic function of period 2 pi by omega. Then what is the Laplace transform of periodic function? L of f of t is equal to 1 by 1 minus e power minus st integral 0 to t e power minus st f of t dt. It is period of f of t. Okay. Here what is the period here? 2 pi by omega is equal to 1 by 1 minus e power minus s into 2 pi by omega integral 0 to t. T means here 2 pi by omega e power minus st f of t dt. Okay, that is equal to 1 by 1 minus e power minus 2 pi by omega s. Now I am splitting the limits 0 to 2 pi by omega as 0 to pi by omega and then pi by omega to 2 pi by omega. 0 to pi by omega e power minus st. 0 to pi by omega f of t value is sin omega t dt plus integral pi by omega to 2 pi by omega e power minus st into the function value is 0. Okay, this is equal to 1 by 1 minus e power minus 2 pi by omega s integral 0 to the second integral remains 0, only the first integral is there, integral 0 to pi by omega e power minus st sin omega t dt. Okay, that is equal to 1 by 1 minus e power minus 2 pi by omega s. Now the integration is e power minus st by s square plus omega square into minus s sin omega t minus omega cos omega t. Between the limits 0 to pi by omega is equal to 1 by 1 minus e power minus 2 pi by omega s. Now the upper limit is pi by omega. Substitute pi by omega here. E power minus pi by omega s by s square plus omega square into, if you substitute omega here in place of t, omega into pi by omega, omega cancels, sin phi. Sin phi is 0 minus omega into, here substitute pi by omega in place of t, omega cancel, cos pi. Cos pi is minus 1. Okay, minus, the lower limit is 0. If you substitute 0, 1 by s square plus omega square into sin 0 is 0 minus cos 0 is 1. Okay, that is equal to 1 by 1 minus e power minus 2 pi by omega s into omega e power minus in minus plus omega e power minus pi by omega s plus omega all by, here the denominator is same, s square plus omega square is equal to 1 by 1 minus e power minus 2 pi by omega s. Take omega common here, 1 1 plus e power minus 5 by omega s into omega whole by s square plus omega square. Okay, so you know that a square minus b square equal to a plus b into a minus b. Now this can be written as this is 1 square minus e power minus 5 by omega s whole square, that is 1 plus e power 5 by omega s into 1 minus e power minus 5 by omega s, and 1 plus e power minus 5 by omega s cancel. This becomes omega by 1 plus 1 minus e power minus 5 by omega s into s square plus omega square. This is required Laplace transform. Next, Dirac delta function or unit impulse function. Okay. What is a unit impulse function? Very large force acting for a short duration of time, like earthquakes, can be represented by a unit impulse function. Okay. Dirac delta function or unit impulse function. Okay. Define a function f epsilon of t minus a is equal to 0 for t less than a, that is 1 by epsilon for a less than or equal to t less than or equal to a plus epsilon, that is 0 otherwise. Okay. Define a function f epsilon of t minus a. Okay. That is f epsilon of t minus a is like this. This is t, this is the function f epsilon of t minus a. This is the interval a plus epsilon. In the interval a plus epsilon, the function value is 1 by epsilon. That means this is the distance 1 by epsilon. Okay. So now, integral 0 to infinity f epsilon of t minus a dt is equal to integral 0 to a f epsilon of t minus a dt plus integral a to a plus epsilon f epsilon of t minus a dt plus integral a plus epsilon to infinity f epsilon of t minus a dt. But the function value is 1 by epsilon in the interval a plus epsilon. Otherwise 0. Okay. That means only the second integral remains, since in the interval a plus epsilon the function value is 1 by epsilon. That is, the first and third integral becomes 0. Integral a to a plus epsilon f epsilon of t minus a value is in this interval 1 by epsilon dt. That is equal to 1 by epsilon into integral dt is t between the limits a to a plus epsilon. This is equal to 1 by epsilon into a plus epsilon minus a, that is epsilon, is equal to 1. Okay. Integral 0 to infinity f epsilon of t minus a dt is equal to 1. That means impulse of this function, this is called impulse. Impulse of this function f epsilon of t minus a is 1. Okay. Integral 0 to infinity f epsilon of t minus a dt is 1. Okay. That means this area is 1. This area is 1. Now let us see what is the Laplace transform of this f epsilon of t minus a. L of f epsilon of t minus a is equal to integral 0 to infinity e power minus st into f epsilon of t minus a dt by the definition of Laplace transform. This is equal to integral 0 to a e power minus st, 0 to a the function value is 0 dt plus integral a to a plus epsilon e power minus st into, in this interval the function value is 1 by epsilon dt plus integral a plus epsilon to infinity e power minus st into, here also the function value is 0. The first and last integrals become 0, only the second integral remains, that is 1 by epsilon into integral a to a plus epsilon e power minus st dt is equal to 1 by epsilon. The integration is e power minus st by minus s between the limits a to a plus epsilon is equal to minus 1 by epsilon s e power minus s into a plus epsilon minus e power minus sa. Okay. Taking e power minus es common, e power minus es into multiplying by minus 1 minus e power minus epsilon s all by epsilon s. This is the Laplace transform of f epsilon of t minus a. Now the limit of f epsilon of t minus a as epsilon tends to 0 is called Dirac Delta function. Is called Dirac Delta function or unit impulse function or unit impulse function, and is denoted by delta of t minus a. Okay, unit impulse Dirac delta function or unit impulse function denoted by delta of t minus a. That is delta of t minus a is equal to limit epsilon tends to 0 f epsilon of t minus a. Now the Laplace transform of this Dirac delta function L of delta of t minus a is equal to, already we find the Laplace transform of f epsilon of t minus a, in that letting epsilon tends to 0, that is limit epsilon tends to 0, Laplace transform of f epsilon of t minus a is equal to limit epsilon tends to 0, Laplace transform of f epsilon of t minus a is e power minus s into 1 minus e power minus epsilon s all by epsilon s. Okay, that is equal to e power minus as into limit epsilon tends to 0 1 minus e power minus epsilon s all by epsilon s. If we substitute epsilon here, that is 0 by 0. Use L'Hospital rule, e power minus s into limit epsilon tends to 0. Its derivative is with respect to epsilon minus of minus s e power minus epsilon s all by s, okay, is equal to e power minus s into, here s cancel here, as epsilon tends to 0, e power 0 is 1. Okay, this is equal to e power minus as. The Laplace transform of Dirac delta function is e power minus as. Okay, we have delta of t minus a is equal to, it's nothing but f epsilon of t minus a as epsilon tends to 0. As epsilon tends to 0, 1 by epsilon is infinity. That means infinity for t equal to a that is 0 otherwise. Okay. So that integral 0 to infinity delta of t minus a dt is equal to 1. Okay. Laplace transform delta of t minus a is e power minus s. Using the definition of Laplace transform and put s equal to 0, you get integral 0 to infinity delta of t minus a dt equal to 1. Okay. Okay students, please do subscribe my channel and share it to your friends. Thank you so much for watching. See you in the next video.